Okay, so we're going to have a look at trying to calculate the beam reactions. So we've got a beam here with 2 point loads, a 20 kilonewton point load and a 50 kilonewton point load, and we know where they're positioned in terms of distances from the pivots and between the forces. So let's call this one reaction A and this one reaction B, and we're trying to find out what those two forces are that are going to support that beam. Now, when you're doing these things, it doesn't really matter which end you start from, but you have to choose which an end. So step one is to choose an origin. So choose a point that you're going to do all your measurements from. And it can be either of the 2 points, the point where one of your unknown forces act. So let's start with our origin being at this end for this time. And then basically the physics is very simple. All you're saying is that whatever's trying to turn the beam anti-clockwise is equal to whatever's trying to turn it clockwise. So anti-clockwise moments equal clockwise moments. It's as simple as that. So all you're saying is, if my beam is fixed at this point, what things are trying to turn it anti-clockwise? So anti-clockwise is that way. So what things are pushing the beam that way? And the only thing is force B is pushing it that way. So anti-clockwise moments is force B acting at 9 meters. Okay, so remembering a moment is always a force times the distance. So we need the force times the distance, and we're measuring the distance from the origin. That's why we put the origin in there. You have to measure it from the origin. And things that are turning it clockwise. Okay, so the 20 kilonewton force acting at 2 meters. It's going clockwise, and also clockwise, the 50 kilonewtons acting at 5 meters. Okay, so those things are both going clockwise, and then it's just a matter of doing a little bit of algebra to figure out what B is. So B is 40 kilonewton meters plus 250 kilonewton meters, all that divided by 9. So that equals 290 over 9. I brought my calculator along. 290 over 9 is 32.2 kilonewtons. Okay, so that tells us that the force B is 32.2 kilonewtons. So we know how much the force B is pushing up with. And then we need to figure out how much the force A is pushing up with. So to do that, we've got a couple of choices, but one of them is certainly just to start at the other end and repeat the process. So now I'm going to put the origin at the other end and try and figure out what's happening for A. So we're now going to go and use our same process again. Do this one in red, seeing it's got a red circle. So we're now going anti-clockwise moments equal clockwise moments. And we're going about force B. So what's going anti-clockwise? Anti-clockwise is this way. So 50 kilonewtons acting at 4 meters. 50 kilonewtons acting at 4 meters. And also the 20 kilonewtons acting at 7 meters. It's turning it anti-clockwise. So 20 kilonewtons at 7 meters. And clockwise, what's pushing the beam back clockwise is whatever force A is at 9 meters. And again, a little bit of simple rearranging gives us A is 200 plus 140 over 9, which is 37.8. Okay, so we end up with knowing what both the forces are. You can actually check whether you've got it right or not, because at this stage you can ignore the moments for a second and just realise that whatever's pushing up has to be equal to whatever's pushing down. Pushing up is A and B, pushing down is the 20 and the 50. A we thought was 37.8, B 32.2. Does that equal 70? Yes, it does. So it confirms that by forces up equal forces down, we can confirm that the two processes we work through give us a sensible answer. Okay, so that's how you work out the beam reactions on what's called a simply supported beam with point loads.